Hi, I'm Salvador, and this is Ben. This is another R video.
And in this video, I'm going to show you how to test for moderation if your moderator is a grouping variable using multiple group models. So, the first thing that we need to do is test for measurement invariance. And we will start by just getting a confirmatory factor analysis of our model with the groups combined. So we have a CFI of 0.986 and a TLI of 0.98, an RMSEA of 0.05, an SRMR of 0.04. We have 281 observations in this example. Now this data comes from an experiment that was conducted in both Saudi Arabia and the United States. And the variables are freedom threat, and so these items are measuring the extent to which the message appeared to be threatening people's freedom. This is a measure of anger, or the extent to which the message inside it made people feel angry. And this is a behavioral intent message, which is whether people indicated that they intended to comply with the health recommendations in the message. So those are the variables we're looking at in the model. This model as a standalone has pretty good model fit. We will actually, now we want to fit this as a multiple group model, and as I said, it's from an experiment that was conducted in the United States and Saudi Arabia. And we're going to use the same measurement model, we just want to fit it on multiple groups. And I have a video on doing measurement invariance in multiple groups. And this does require doing measurement invariance. And so you need to do those steps first. And we'll do those steps here, but I won't really be looking through it or talking through it or demonstrating any of it. And so if you haven't learned how to do measurement invariance or conducted that analysis on your data, you need to do that first. But all we need to do to fit this as a multiple group CFA is add group equals and then the name of the grouping variable in your data set. And here our grouping variable is named country. Oops, what's going wrong here? We want that to be model 1 because we're using the same model description for both models, so just call it model 1. Then we get the summary of the multiple group model. So one thing you'll notice, it says group 2 SA. That means that this was the CFA for the Saudi sample. Group 1 is US. That's obviously the US sample. The SRMR is 0.05. The RMSEA is 0.06. The CFI is 0.981 and the TLI is 0.973. So this is a nice fitting multiple group model. To establish measurement invariance, we'll first look to establish weak invariance by constraining all of the loadings to be equal. And you can do that in Lavon just by typing group.equal equals, then in quote marks, loadings. So that's group.equal equals, and then in quotation, loadings. And so if we fit this, we should notice that we get, let's see, did this work? I'm not seeing that this worked. What did I do wrong? Group.equal equals loadings. Oh, did I scroll up too far? That's why it didn't work. I scrolled up too far. Okay, sorry about that. So you see we get the number of equality constraints up here is 10. That's always a good thing to check. That's because we have 10 indicators. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll see that we get, you can also check that we now have 7 more degrees of freedom. And we see that the CFI is 0.979. We can see the equality constraints here, the names that it's given the loadings in the US group. We'll see that those are the same names as it gives in the Saudi group, and that these loadings are in fact the same. So if we just look at the first one, 1.595, We scroll down to the loadings in the Saudi group, 1.595. The names are all the same, and these are the equality constraints that it's talking about. We've constrained all of the loadings to be equal. Now, to establish whether we have measurement invariance, the recommendation is to check for a change in CFI. And so we want the CFI for fit 2 and the CFI for fit 3. And we can get that by typing fit measures fit 2 CFI. And that tells us that the CFI for fit 2 is 0.918. The CFI for fit 3 is 0.979, so the CFI only went down 0.002 points. The recommendation is that the CFI should only go down 0.01, and so we're less than that, so we pass the weak invariance test. And again, for more on this, I have a whole video on measurement invariance. We're trying to speed through this so we can get to checking for moderation by group. Now, to get strong invariance, we need to constrain the loadings and intercepts to be equal. So we just, anytime you're making a list in R, of course, you use C parentheses. So on that group.equal command, it now says group.equal equals C left paren quote marks loadings, close quote, comma, open quote, intercepts, close quote, left, right paren, right paren. And so we add that to our fit4 command. And now we see we have all of these equality constraints for the intercepts. And we see that intercept for perceived freedom threat 1 is 3.154. If we scroll up to the next group, it's 3.154. We see they have all the same names here, so that's the equality constraint. If we scroll up to the top, we see that there are 20 equality constraints. We get our model fit, and we can directly compare. So we're comparing the CFI from fit 3 of 0.979 to fit measures fit 4 CFI. And so we're comparing 0.979 to 0.971. So it's a change of 0.008, which is still lower than 0.01. So we have strong invariance as well. So we've established measurement invariance. Now we can get to the part of the video where I show you what you came here for. How to see if your regression paths are moderated by the grouping variable. In other words, here we'll be interested in testing whether the effect of the experiment is different depending on whether you're in the US sample or the Saudi sample, and we're going to test one other relationship to see if it's different depending on the sample. So we're copy and pasting the measurement model, and we're naming it model 5. So this is our 5th model. But to this we have to add the regression paths. So we're going to say that behavioral intent is a function of freedom threat and anger. So BI tilde FT plus ANG. Then we're going to say that freedom threat is influenced by our experimental conditions. And so our experimental conditions are auth and AUTH and NORM. The AUTH stands for authoritarian, which is a message about mask mandates and making people get vaccines and making people go back into lockdowns. And the norm message is just saying, hey, a lot of people are doing that and they want you to too. So, and then there's a control message. That's the reference here. So this is a dummy variable for were you in the authoritarian condition, and this is a dummy variable for were you in the norm condition. And we're saying that freedom threat and anger are both going to be influenced by the authoritarian and the norm condition. Now, that is just adding our regression paths to our measurement model. So we describe model 5 that way. When we fit model 5, so fit 5, mod 5, we want to add to our group.equal list after the loadings and the intercepts. After intercepts, add another comma, and then in quotation marks, write regressions. And what that's going to do is constrain all of the regression paths to be equal across groups. Now that might not be a tenable constraint as a global constraint. And you can say, well, why don't I actually estimate each regression path independently for each group and then constrain them one at a time to see if they're equal, rather than constraining them to be equal all at once and then testing them iteratively. The reason that you would constrain them all to be equal first and then test each path to see if that equality constraint is tenable is that the assumption that the paths are equal in both groups is consistent with the null hypothesis, that there are no differences in effects across groups. And so if you have a hypothesis that there will be a difference between the coefficients between the groups, then you would test that hypothesis against the more restricted model. So you want the parent model to be the more restricted model, and then you only want to test for moderation where you have a theoretical hypothesis that says that there should be. So we're going to do fit 5 and then get our summary of fit 5. And here, so this is, the first group we get is group 2, which is the Saudi group, the Saudi Arabia sample. And again, we have these equality constraints on the regression path, and then we also have these estimates for whether there were any effects. And the only significant effects in this model are freedom threat on behavioral intention. So people who felt like the message was threatening their freedom were less likely to comply with the recommended health behavior. And then we also see that the authoritarian message increased freedom threat perceptions. So the message that was really commanding with a "you must do this or there will be penalties," that message increased freedom threat. And if we go up to the US sample, we're going to see the exact same coefficient sizes and the exact same p-values because we've imposed this equality constraint. But we actually want to test to see whether those constraints are tenable. And we can see that the CFI and the TLI have gone down in our model fit, suggesting that at least one of these equality constraints may not be tenable. And you can look to see which equality constraint isn't tenable by looking at your modification indices, but that might encourage data-driven respecification, and we want to test the theoretical hypotheses. So to do that, we're going to create a copy of Model 5. We'll call it Model 5.1 to communicate to ourselves that it's nested within Model 5. The names we're giving them are arbitrary. It doesn't matter what you name them. Now, what we want to do first is see if the effect of freedom threat on behavioral intention is different across samples. The student that designed and conducted this study was thinking that freedom threat would have a stronger relationship with behavioral intention in the United States, where there's a lot more psychological reactance, compared to in Saudi Arabia, where there is more of a culture of authoritarianism and more of an authoritarian social structure. So, to free the regression estimate across groups, we need to create a name. We need to give each regression estimate a unique name. And to do that, we need to create a new list. So we'll go C parentheses to create our list. As always, when you make a list, you use C parentheses. And then we put an asterisk to attach whatever we put in this list to this path, to the freedom threat on behavioral intention path. Now, if we just put in the C parentheses A, comma, B, what that'll do is it'll name the coefficient for freedom threat on behavioral intention. It'll name that coefficient A. And it'll name, that's for the US sample, for group 1. And for group 2, it'll name the coefficient B. By giving the coefficients unique names, that tells Levon to estimate them independently. So I'll show you what happens when we've done that. So now, if we look at the regression coefficients in group 2, Saudi Arabia, we see that the name of this freedom threat on behavioral intention coefficient is now B. And we see that the estimate is negative 0.217, and the p-value is 0.008. So freedom threat is still significantly associated with a decrease in behavioral intention. we notice that the coefficient for Saudi Arabia is now negative 0.217. If we go to the US, Group 1 US, we see that the coefficient is now named A, so not B, A. It has a unique name, the first name that we gave it in the C listing. So that's where those names come from. And we'll see that the coefficient is negative 0.659. So that coefficient is considerably larger than the coefficient for Saudi Arabia, which is 0.217. So it looks like though freedom threat still is associated with reduced behavioral intention in both the US and Saudi Arabia, it looks like freedom threat is a lot more powerful in the US compared to Saudi Arabia. Now, this is, what we would call eyeballing it. We see that the coefficient is larger in the US context, but is that difference in coefficient statistically significant? And to do that, we would want to compare the change in chi-square. So the chi-square value in this nested model is going to be lower than it was in the previous model. So if we compare the chi-square for fit 5 to fit 5.1, in fit 5.1 the chi-square is 190 and the degrees of freedom are 117. If we look at 5.0, the degrees of freedom are 118, but the chi-square statistic is 202.5. So the chi-square is higher because this model fits the data worse. The reason that the parent model fits the data worse is because it was imposing an equality constraint on that freedom threat coefficient, and we know that those coefficients weren't the same. So the model fits worse. But we have one more degree of freedom because instead of estimating a unique coefficient for each sample, we're only estimating one coefficient for them to share. So in the parent model, we have 118 degrees of freedom with a chi-square statistic of 202. If we scroll back down to the nested model, where we freely estimate that, we get one fewer degrees of freedom, only 117 degrees of freedom, because we have to spend a degree of freedom to estimate a unique path for each sample. So by estimating two coefficients for freedom threat instead of one, we're reducing our degrees of freedom by one. But we're also improving our model fit. So the chi-square statistic of misfit goes down from 200 whatever to 190. Now, it's perfectly fine to just scroll between the two outputs, look at your chi-square, look at your degrees of freedom, and then look up the change in chi-square on your critical values table. But there is a more efficient way to do that if you use the package SEM tools. So we'll go install.packages SEM tools, and I've already installed it in my device, and then load it, library SEM tools. The T is capitalized, so SEM capital TOOLS. Now, the way that you compare nested models using SEM tools is the ANOVA command. I don't know why they call the command ANOVA. I'm sure it makes sense to the people that wrote SEM tools, but it's called ANOVA. And so our first model is fit 5, the parent model, and then the nested model is fit 5.1. And if we run that command, just ANOVA fit 5.1, it gives us the model fit for fit 5. So it says fit 5.1, degrees of freedom 117. It gives us the AIC and the BIC. Then it gives us that chi-square 190.15. And then it gives us the model fit for fit 5, which is 118 degrees of freedom. It gives us the AIC and the BIC, and then it gives us that chi-square of 202.53. Then it gives us the chi-square difference, which is 12.375. And then it gives us that 1 degree of freedom difference, and then it gives us the p-value telling us that on 1 degree of freedom, a chi-square change of 12.375 is statistically significant. So this chi-square difference test tells us that in fact, these coefficients, the coefficient of freedom threat on behavioral intention, is different in the US sample compared to the Saudi Arabia sample. In other words, the effect of of freedom threat on behavioral intent is stronger in the US than it is in Saudi Arabia. Now, we can run this same test for any coefficient that we want to make this comparison on. So we'll take model 5.1. We're going to leave those paths, we're going to leave that code in there to indicate that the paths have separate estimates, because that is the superior model. We're concluding that those effects aren't the same across paths. Now we want to see if the authoritarian message has a different effect on freedom threat. So did US respondents perceive the authoritarian message to have more freedom threat in it than did the Saudi participants? Now, it's important, we're going to add the same C parentheses, and then the names with the asterisk to attach it to the coefficient. But we need to change the names. We can't use A and B again because they're already used. If we named the coefficient for authoritarian message on freedom threat A, we would be saying that coefficient is the same as the coefficient of freedom threat on behavioral intention. So this would be an inadvertent equality constraint. So we'll call the paths C and D. We'll name those paths C and D so that they can have unique names. So this is the effect of the authoritarian message on freedom threat. We've named the coefficients C and D with the syntax C parentheses, C comma, D, close parentheses, asterisk. Now, we need to call this model 5.2. So change it from 5.1 to 5.2 throughout your syntax. We run it. We get a summary, and now we see that in the Saudi Arabia group, the effect of authoritarianism on freedom threat is positive 0.212, so the authoritarian message was associated with more freedom threat. It's not quite statistically significant, or it's not statistically significant. And then if we look in the US, we see that the effect is 0.4, so 0.4 certainly seems like a larger effect than 0.2, right? It's basically double the size, and it's just barely statistically significant, 0.04. But the question is that apparent difference, are we statistically confident that that apparent difference is true? And so we see, remember we had 117 degrees of freedom before, now we have 116 degrees of freedom. But we can already see that the test statistic is 189.6, so that is a change of chi-square of maybe 1, maybe less than 1. And if we run that ANOVA comparison to get the exact change in chi-square, we can compare fit 5.2 to fit 5.1. Remember, this isn't an ANOVA, it's a chi-square difference test. They just named the command ANOVA. I don't know why, but I'm sure they do, and I'm sure it's a smart reason. So we see on 1 degree of freedom, the chi-square change is only 0.53, and that's not statistically significant. So we actually would conclude that the effect of the authoritarian condition on freedom threat is the same in both groups. Now that might be an issue of statistical power, right? Like here it's saying, let's get a summary. Oh yeah. It appears that there's a difference, right? 0.2 compared to 0.4 for the coefficient. But that apparent difference isn't big enough given our power to say with confidence that it's a statistically significant difference. So we would conclude that the authoritarian message had an effect on freedom threat regardless of whether it was a message read in the Saudi sample or a message read in the US sample. So those are two examples, one where the hypothesis of moderation is supported, and one where the hypothesis of moderation is not supported. And hopefully, that's a useful illustration of how to use multi-group models in SEM to test for moderation. I think this is a really cool application of structural equation modeling. I think it's maybe one of the most interesting uses of it because the message and all of the measures were translated into a second language for use in the Saudi sample, and it's a different culture. there are different, different political climate, different social climate, and so it's interesting to test if this, if psychological reactance theory, this theory developed in a Western context, is applicable. But in order to make that test, we have to demonstrate that that people understand the messages to be meaning the same thing, that people understand even the measures to be meaning the same thing. So the ability to demonstrate measurement invariance, and then the ability to see if the effects that we think to be the same across cultural context are in fact the same across cultural context, I think that's a really interesting and powerful application of structural equation modeling. So hopefully you find this video helpful, and hopefully you'll think of really creative applications of this in your own work. Thanks for watching, and if you like these videos, subscribe so that when I publish a new one, you'll be the first to see it.